welcome you all on my YouTube channel, and today we will move one step ahead in the chapter solutions. Okay, so in the last videos we have started with solution chapters and we have seen about the colligative properties. We have started with the colligative properties and we have seen the first colligative property, that is lowering of vapor pressure. Okay, so today we will continue with the further topics, that is the second colligative property, and that is boiling point elevation. Okay, in the boiling point elevation we will be coming across the we will compare the boiling point elevation with the vapor pressure. Then we are going to with the lowering of the vapor pressure, then we are also going to calculate the concentration of the solute from boiling point elevation. Also we will see we will calculate the molar mass of solute using the boiling point elevation, and we will see some numericals on it. Okay, but before moving ahead, in the last video I have explained you what are colligative properties, and so let me ask you one question on it. We all know that colligative properties are those properties which do not depend upon the nature of the solute but depend only on the number of the solute particles. Okay, this we have seen. Now if I asked you, suppose if two solutions are prepared by dissolving 5 moles of urea and 5 moles of glucose, okay, then what will be the effect on lowering of vapor pressure? Means what will be the effect on the colligative property? Will it be same or will it be different? Yes, the answer is yes, both will have the same colligative property. Why? Here you can see that this is a glucose solution and this is a urea solution. Okay, in both the solutions the concentration is the same, that is we are taking 5 moles of glucose and 5 moles of urea. Suppose to make it more simple, let me say that in the solution A I have added 5 molecules of glucose, and in the solution B I am adding 5 molecules of urea. Okay, means the number of the particles in both the solutions are same. But the second condition for colligative property is that both the solutes or any solute that we are adding should be non-volatile. Should be non-volatile as well as non-ionizable. Means both the whatever solute we are adding, it should be a non-electrolyte. In simple I should say it should be a non-electrolyte, and non-electrolyte means non-ionizable and non-volatile. Now what do we mean by non-volatile that we have seen in the last video? Now in this case neither glucose nor urea, both are not volatile. Secondly, non-ionizable means one, the solute which should not get ionized when dissolved in water. Okay, so in this case neither glucose nor urea dissociates into ions when dissolved in water, and hence both the solutes are non-ionizable in nature, and hence the total number of the solute in both the solutions is the same, and hence both will have the same colligative properties. Okay, now let us see one more example. Suppose if I am saying that I have prepared two solutions by dissolving 5 mole of NaCl in one and 5 mole of glucose in another. So what do you say? In this case, will the colligative properties be same, or will the vapor pressure lowering be same for both the both the solutions? Yes, you are right that the colligative property or the lowering of the vapor pressure will not be same in both the cases. Here in this case, they will not be same. Lowering of vapor pressure will not be same. Now why? Again, in this case also, both the solution contains same concentration of solute, and according to the colligative properties, it doesn't matter what you are adding. What matters is the number of the particles. So, in this case, both have same particles. Then why the colligative properties are not same? Yes, because one solute is non-ionizable and the other solute is ionizable. So, in this case, glucose is non-ionizable and NaCl is ionizable. So, when I am adding 5 moles of glucose means, in simple I should say that if I am adding 5 particles of glucose, after getting dissolved in the water, it will remain 5 molecules only. But when 5 molecules of NaCl get dissolved in water, then these 5 molecules of NaCl dissociate as 5 Na plus and 5 Cl minus ions, and therefore these in the NaCl solution there will be 10 molecules according to the if we see, then it becomes 10, 5 molecules of Na plus and 5 molecules of Cl minus. So total number of particles in NaCl will become 10, and hence the vapor pressure lowering will be double as compared to that of the glucose. Okay, have you understood this now? Now let's move ahead. So now let's see our second colligative property, that is boiling point elevation. Now first of all, what is boiling point? Okay, when I'll ask you what is boiling point, everyone knows that whenever a liquid, the temperature at which the liquid starts to boil, that is nothing but the boiling point of a liquid. But at this point you are expected to give some more specific answer about what is boiling point. So what happens, why do the liquid boils? Why at a particular temperature, why does it start boiling, or why does it gives out bubbles? Okay, when the solution boils, it gives out bubbles, yes? So why does it give bubbles and why does it boils? So the answer is that the boiling point is not just the temperature at which the solution boils, but actually what happens when the liquid, whenever the vapor pressure of a liquid or vapor pressure over the solution, over the liquid, over the solution becomes equal to the atmospheric pressure, at that point the liquid starts to boil. So we can define boiling point as the temperature at which the pressure exerted by the surrounding, atmospheric pressure is nothing but the pressure exerted by the surrounding upon a liquid, is equal to the vapor pressure exerted by the over the liquid. Under this condition, the addition of heat results in the transformation of liquid into its vapor without raising the temperature. So after that point, once the boiling point has been reached, once that temperature has been reached when the liquid starts boiling, after that the temperature will not raise. Okay, at the same temperature the liquid will remain boiling. Okay. So what let's understand it in more better manner. What is he saying? That temperature at which the pressure exerted by the surrounding. Now what is the pressure exerted by the surrounding? We all know that we are surrounded by an atmosphere. An atmosphere consists of many gases. These all gases, like us, are attracted by the gravitational force towards the earth. So all these gas molecules are pulled towards the earth, and when they are rushing towards the earth, when they are trying to come near the earth, what happens? These molecules will collide with each other, and whenever there is a collision, it will create a pressure. So all these molecules are creating a pressure, and that pressure is called as the atmospheric pressure. Now, if we are taking a liquid in an open container, then what happens? These molecules exert a pressure on the liquid. So, when this pressure is called as the atmospheric pressure, and when this pressure becomes equal to the pressure exerted by the vapors, we all know that a volatile solute create a vapor pressure. Okay, because for a volatile solute, the liquid molecules get converted into the gaseous phase, and when they get converted into the gaseous phase, they collide among each other and create a pressure, to which we called it as a vapor pressure. So when this atmospheric pressure and the vapor pressure becomes equal, under this condition, what will happen? The heat will increase due to that collision, due to the molecules of the atmosphere and due to the collision of this vapor pressure. So when these two molecules create a pressure among each other, what will happen? Whenever we create a pressure, what happens? Heat is generated. So that heat is generated inside the molecule, which helps the liquid to boil. Okay, so it transforms into the vapor, and that is nothing but the boiling point. So Boiling point is nothing but a temperature at which the pressure exerted by the surrounding upon a liquid is equal to the pressure exerted by the vapors of the liquid. Under this condition, addition of heat results in the transformation of liquid into vapor without raising the temperature. Okay, so have you understood? Now let's see one beautiful video over it, how this boiling takes place. Okay, so see over here. Now these are the these are the molecules which are there present in the atmosphere. These molecules are continuously moving around there, and when they come in contact with the surface of the water, what happens? They are going to create some pressure over this surface of the water, and this surface, the pressure that is created by this over this surface is known as the atmospheric pressure. Okay, now there are the molecules of water also, and water is getting escape as it is volatile in nature. So these molecules will also create a pressure which we will call it as a vapor pressure. Okay, so when these two atmospheric pressure and the vapor pressure becomes equal, at that point the liquid starts to boil. Okay, vapor pressure become equal to the atmospheric pressure. That is known as the boiling point of the liquid. Now what happens? How does it happen? So in this liquid, whenever the atmosphere create a pressure, okay, when the atmosphere creates a pressure, these molecules are it is not possible for these molecules to escape out from the water, from the liquid phase, and get converted into the vapor phase easily, and therefore generally the water remains stable, okay, at room temperature or at an ordinary temperature. But as we start to give heat to it, what will happen? The kinetic energy of the molecules inside the water will increase, and the increase in the kinetic energy will now allow all the water molecules to get converted into the vapor phase. You can see now the kinetic energy, due to this kinetic energy, these molecules are now pushed apart, and which is creating a, here you can see that it is like a circle. So this is not a circle, but this is a bubble that is formed inside the liquid. When these molecules, when a kinetic energy increases, these molecules get apart from each other, and a bubble is produced. So now these molecules can easily escape into the atmosphere, and the vapor pressure goes on increasing. And when this vapor pressure becomes equal to the atmospheric pressure, then the liquid starts to boil. Okay, in this way it starts to boil. You must all have seen this at your home many a times, that it gives bubbles. So it gives bubbles due to this. Okay, there is an increase in the kinetic energy, and therefore, or even you can see a simple example. Without heating, if you take generally, have you understood what is boiling point? Yes, so boiling point is simple to understand. Just whenever the vapor pressure become equal to the atmospheric pressure, the liquid starts to boil. Whichever liquid it may be, it starts to boil. And different liquids have different boiling point. Okay, different liquid have different vapor pressure, so accordingly that they will have a different boiling point. Okay, now we will come to our main point, that is the colligative property, second colligative property, that is boiling point elevation. Boiling point elevation. Boiling point elevation. Elevation means to increase, means boiling point get increased. When does the boiling point get increased? When we are going to add a non-volatile solute in a particular solvent. Okay, what we are saying, that if we are going to add a non-volatile solute to a volatile solvent, then the boiling point of that solute, of that solvent increases, and this is nothing but boiling point elevation. Okay, in simple words, I can say that a solution which contains a non-volatile solute boils at higher temperature than that of the pure solvent. Okay, simple example I would like to give. You all must during now, since it is a quarantine time for all of us, everyone has become a chef now. Yes, so everyone is trying something or the other to cook something or the other in the kitchen. So all must, girls or boys, all must have come, you must all have observed this, but you must have never related it with our solution chapter. Now I will tell you the example. See, when you keep a water, okay, for boiling, okay, to make a tea or something else. So whenever you are taking, generally tea, all must know how to prepare a tea. So let's take an example of tea only. So what happened when you are keeping a container of water for heating? What happens? It starts boiling. But as you add the sugar to it, okay, as you add the sugar to it, either to the water or to the milk, when you add a sugar to it, what happens? The boiling stops, or the temperature, the boiling temperature has now stopped, and after 2 seconds or after 3 or 4 seconds it will again start boiling. Means what? Yes, the boiling point of, initially the boiling point of water, we know that the boiling point of water is 100 degrees Celsius. But when you added that solute into it, when you added that sugar into it, what happened? Due to that sugar, the boiling point has not remained 100, but it has increased to some 2 or 3 degrees Celsius. So when your burner again gives the heat and it increases the temperature, so after 2 or 3 seconds, when the temperature has raised to its elevated point, at that point your sugar again starts boiling. Yes, so this is nothing but a simple example of boiling point elevation. Okay, now we are saying that it should, the condition should be the same in this case also, that the solute should be non-volatile solute or non-electrolyte solute, because non-electrolyte means non-ionizable and non-volatile both. So whenever we are adding a solute to it, and if we are observing the boiling point elevation, then this property of the solute is that it should be non-electrolyte. Okay, so this is boiling point elevation. Let's see one video on it. See, now in this case, here you can see that I have kept the container, or I have kept the sugar molecule, which generally, or a solvent whose boiling point is 40 degrees Celsius. Okay, now I am adding a non-volatile solute to it. So after adding a non-volatile solute to it, the boiling point will be raised. The boiling point will not be 40 degrees, but it will be some 42 or 44 degrees Celsius. This is nothing but the boiling point elevation. Now the boiling point has become 45 degrees Celsius. So this is a simple video to show that how the boiling point elevation takes place. So now let us mathematically see what is boiling point elevation, or mathematically derive what is boiling point elevation. So suppose if T be naught, let me consider that the temperature is denoted by capital T, and since it is for the boiling point, let us denote it by T small b. So T be naught is the boiling point of pure solvent. Okay, whichever is the pure solvent you are taking, in which we have not added any solute, it is in pure form. So for that the boiling point is suppose T be naught, and after adding a solute to it, a new temperature is obtained and new boiling point is obtained, and that is suppose denoted by TB. Okay, now just we have seen that the boiling point has increased, means the value of TB will be much higher than TB naught. Okay, so TB is greater than TB naught, and if I find out the difference between the two, that will give me the elevation in the boiling point, means at about how much degree the boiling point has been increased. So the difference between the boiling point of the solution and that of the pure solvent at any given constant temperature is called boiling point elevation, which can be equated as delta TB. Difference is generally taken as delta TB. So delta TB is equals to TB minus TB naught. Okay. Okay, now let us relate it with the vapor pressure lowering, boiling point elevation as a consequence of vapor pressure lowering. Okay, both are interrelated. How? Now what I have said, boiling point is boiling point means the point at which the atmospheric pressure and vapor pressure becomes equal. That is known as the boiling point. Now we have said in the previous point when we were studying with the vapor pressure, then what happens when a non-volatile solute is added to a solvent? What happens to the vapor pressure? Yes, the vapor pressure get lowered. Okay, means it decreases. The vapor pressure of the pure solvent is higher and that of the solution is lower. Means whenever we add a solute, the vapor pressure decreases. Okay. So, if the vapor pressure will decrease, what will happen? It will take more time to reach to the to become equal to that of the atmospheric pressure. Yes. So, obviously, the boiling point will increase. Means this is a relation between the boiling point elevation and vapor pressure lowering. Once if the vapor pressure is getting lowered, then obviously the boiling point will increase. Okay, because lowering of vapor pressure means it will take more time for the vapor pressure to equal to the atmospheric pressure, or it will take more energy for the molecules to cope up with that atmospheric pressure. Okay, so what it says, that whenever a non-volatile solute is added to the solvent, the vapor pressure decreases and boiling point increases, and hence the lower the vapor pressure, higher will be the boiling point. जितना कम होगा vapor pressure, उतना ही boiling point ज़्यादा बढ़ता जाएगा. This is the consequence of the boiling point and the vapor pressure lowering. Okay, so let us find it out Mathema in the graphical form. Now, if I plot a graph between the vapor pressure and the temperature, okay? On the x-axis I have taken temperature and on the y-axis I have taken vapor pressure. Okay, so what happens? This is the vapor pressure of the pure solvent. So the value of the vapor pressure, suppose this is 0.5. So 0.5 till 1 atmosphere it is going on the vapor pressure, as this is the vapor pressure. So the vapor pressure of the solvent and this is the vapor pressure of the solution. So what does this graph signifies us? That the vapor pressure temperature of the pure solvent and solution shows that the boiling point of the solution is higher than. Okay, see here this is the vapor pressure. Okay, so this is the vapor pressure. If this is the vapor pressure, this becomes the boiling point of that solvent, and this is the vapor pressure of the solution, which gives the boiling point of the solution. So from this graph you can see that the boiling point has been increased by adding a non-electrolyte or non-volatile solute to a solvent. So initially the boiling point of solvent was this, and after the completion, after the addition of this non-electrolyte solute, the boiling point has reached to this point, means it has increased, and the difference between these two is taken as delta TB. Okay, now next is boiling point elevation and concentration of solute. So we are going to calculate out the concentration of the solute from the and going to relate it with the boiling point elevation. Now here it says that the boiling point elevation is directly proportional to the molality of the solution. Okay, so when the experiments were done, most of the scientists have done a work over it, and they concluded that the difference or the elevation depends upon the concentration, and again the concentration depends upon the number of the moles. Okay, here it is said that the boiling point elevation is directly proportional to the molality, and we know that molality is number of moles of solute present per kg of solvent. Yes, so again here there are number of moles, means boiling point elevation is also a colligative property because it depends only on the number of the solute particles and not on their nature. Okay, so boiling point elevation, when we relate the boiling point elevation and concentration, then it was found that the boiling point elevation is directly proportional to the molality of the solution. That is, now boiling point elevation is given by delta TB, so it is directly proportional to the molality, and molality is denoted by small m. Now if I want to remove this proportionality sign, then I have to keep some constant over that. Let me name that constant as Kb. So delta Tb will be equals to Kb into m, where this m is the molality of the solution and Kb has now become the proportionality constant, which is called as the boiling point elevation constant or molar elevation constant or ebullioscopic constant. And in general, most of the times in the exam, they generally give the word ebullioscopic constant. So ebullioscopic constant is nothing but the constant which equates the boiling point elevation and molality. Okay. So thus ebullioscopic constant is the boiling point elevation produced by 1 molar solution. Now let us derive the units for this Kb. Now if we equate this equation as a Kb, then Kb will be equals to delta Tb upon m. And delta Tb is nothing but temperature. So temperature is given either in Kelvin or in degrees Celsius. So this is Kelvin upon. Next is molality. Molality is number of moles present in 1 kg of the solvent. So mole per kg. So its unit is mole per kg, and hence the total unit for this Kb will become Kelvin kg per mole or degree Celsius kg per mole. Okay. So this is all about boiling point elevation and concentration of the solute. Now let me ask you, why the concentration of solute is expressed in mole per kg and not in molarity? This question is mostly asked in the papers, or in the competitive exams also this question is asked, that why the boiling point elevation, or why whenever we study the boiling point elevation, then the concentration of solute is expressed in molality and not in molarity. Do you know why? Yes, because in this case what is happening, boiling point is related with temperature. Okay, and the molarity means number of moles present in 1 liter of solution, means there the volume is given. Okay, we are considering the number of molecules present in particular volume of solvent. So that volume, if the temperature changes, then that volume will also change, and hence it will not be correct to relate the boiling point elevation with molarity, and therefore molality is generally preferred than molarity, because in molality there is no temperature factor. Molality means number of moles present in per kg of solvent. Okay, so whenever we are considering a solid thing, so it doesn't have a much effect on the temperature as compared to that of the when we are considering the volume. Okay, so we can answer it in this way. When we are studying the boiling point elevation, we are dealing with the system whose temperature is not constant, and therefore we cannot express the concentration of solution in molarity which changes with the temperature, and therefore generally the molality is preferred than the molarity. Here again I have given the reason for it. Molality is number of moles present in per kg of solvent, and this molality does not depend on temperature. Neither the number of moles of solute and nor the mass of the solvent will be affected by the change of temperature. Whereas in molarity is number of moles of solute present in per volume of solution in liters. Actually it should be liters. I have made a mistake over here. It should be liters. And this changes as the temperature changes. Molarity decreases with increase in temperature. And here the number of moles are independent of temperature, but the volume increases with the increase in temperature. As you are going to increase the temperature, the molecules inside the liquid, they are going to evaporate, and hence the volume will be increased, and therefore it is a temperature dependent factor, whereas molality is temperature independent factor, and hence molality is preferred as compared to molarity. Okay. Now next, the last topic is molar mass of solute from the boiling point elevation. Now we are going to relate the boiling point elevation with the molar mass. Okay. Now just we have said that delta Tb is equals to Kb into small m. Okay. Now suppose if I am considering that I have prepared a solution in which I have added W2 grams of solute and W1 gram of solvent is there. Okay, so the number of moles is nothing but the mass upon the molar mass. So solute. In this case, the solute we are taking W2 gram. Therefore, number of moles of solute will be W2 gram upon the molar mass, that is M2. Suppose let me consider that M2 is the molar mass of solute and M1 is the molar mass of solvent. So, in this case, the number of moles of solute will be W2 upon M2. Okay. Then similarly, the mass of the solvent, in this case I have taken W1 gram. So W1 gram, always we know that molality. In molality we express the weight of the solvent in kg. So I have to convert this gram into kg. So this will become W1 upon 1000 gram per kg. That will become W1 upon 1000 kg. I have converted this mass of the solvent in kgs, W1 upon 1000 kg. Now, and we know that molality is moles of solute upon mass of solvent in kg. So, moles of solute, we have just calculated moles of solute as W2 upon M2. Therefore, W2 upon M2 upon mass of solvent in kg, and mass of solvent in kg is W1 upon 1000. So, it becomes W1 upon 1000 kg. Now, this new when I equate this, if I want to equate such equation, what I will do, I will just invert the denominator. So W2 upon M2 into 1000 upon W1. This can be also written like this, and therefore the molality M will be equals to 1000 into W2 upon M2 into W1. Okay. Sorry, here also I have made a mistake. It should be M2. Okay, W2 upon M2. So sorry, it has been by mistake I have written it W1. So W2 upon M2 into 1000 upon W1. So molality is 1000 into W2 upon M2 into W1 moles per kg. Now let us substitute the value of this M in our first equation, that is delta TB is equals to KB into M. So it will become delta TB is equals to KB into 1000 W2 upon M2 into W1, where W2 is the weight of solute, W1 is the weight of solvent, M2 is the molar mass of solute. So if I want to find out, the aim was to find out the molar mass of solute from boiling point elevation. So I have to equate molar mass. I have to keep the molar mass on the left hand side in order to get its value. So M2 will be equals to 1000 into KB into W2 upon delta TB. This will come down, delta TB into W1. M2 has gone on to the numerator, so delta TB will come in the denominator. And hence our equation becomes M2 is equals to 1000 KB into W2 upon delta TB into W1. You have to keep this formula in your mind because most of the time the numericals are asked on it. Okay, let us try to solve one numerical. So, the normal boiling point of ethyl acetate is 77.06 degrees Celsius. Okay, and a solution of 50 gram of non-volatile solute in 150 gram of ethyl acetate boils at 84.27 degrees Celsius. Evaluate the molar mass of solute if Kb for ethyl acetate is 2.77 degrees Celsius kg per mole. Okay, the numerical is very simple. All the things are directly given. So first let us compute what is given to us. Okay, so let us write down what is given to us. So again we'll start reading. So what is saying? The normal boiling point of ethyl acetate means it is the solvent. Ethyl acetate, we have understood that ethyl acetate is a solvent in which we are adding some 50 gram of non-volatile solute. So this ethyl acetate boils at 77.0 degrees Celsius, 06 degrees Celsius. So this is nothing but the value of TB. Okay, so TB naught, TB naught for the pure solvent we have given not here there. So TB naught is 77.06 degrees Celsius. Then further he is saying that a solution of 50 gram of non-volatile solute means the weight of the solute is given. Weight of solute is taken as W2. So W2 is given to be 50 gram. So W2 is 50 gram. In 150 gram of ethyl acetate means this is the weight of the solvent. So weight of solvent is given by W1. So that is W1 is 150 gram. it boils at 84.27 degrees Celsius. Means after adding a non-volatile solute, the boiling point has raised, because the boiling point generally gets elevated when we add a non-volatile solute. So in this case also it is getting elevated, and it has now reached to 84.27 degrees Celsius. So this is the value of TB. So TB is 84.27 degrees Celsius. Then he is saying evaluate the molar mass. Means we have to find out the molar mass of what? Of solute. And molar mass of solute is given as M2. So M2 is to be found out if Kb for ethyl acetate, if Kb for ethyl acetate is 2.77 degrees Celsius Kg per mole. So the value of Kb means abelioscopic constant or molar elevation constant, or I should say the boiling point elevation constant. Anything we can say. So the value of this Kb is given as 2.77 degree Celsius. Okay. So let us just, you have to keep all these values in the formula and you have to find it out. Let's calculate it out. Now we know that M2 is, just now we have derived it as M2 is 1000 into Kb into W2 upon delta TB into W1. So 1000, let me substitute all the values. Now here delta TB, first let us calculate out delta TB. Delta TB is TB minus TB naught. So here TB is 84.27 degrees Celsius and TB naught is minus 77.06 degrees Celsius. So if we find out the difference between the two, we get 7.21 degrees Celsius. So the delta TB value is 7.21 degree Celsius. Now let us substitute all the other values in this formula and calculate it out. So M2 will be equals to 1000 into Kb. Kb is 2.77 degrees Celsius Kg per mole. Always try to write the units, so that it will not be a difficult task for you to at last you have to write down the unit, or unit contains separate marking. If you don't write the unit in the answer, then 0 marks is given over the answer. Okay. So if you are going to write down the units along with the substitution part, then it will be easy for you to just come out with the unit when you are deriving the answer, or when you are finding out the answer, it will automatically come out with the unit. Okay. So always make a habit of writing unit along with the values. So here 1000 into 2.77 degrees Celsius Kg per mole into W2 is the weight of solvent, and since we are taking the weight of the solute in kg, so we have to take all the quantities in kg only. So we have to substitute here, we have to convert. Here we have given 50 grams, so it has to be converted into kg. So it can be converted into kg by just dividing it by 1000. So 50 divided by 1000 per kg. Now it has become upon 84.27 minus 77.06 into 150. W1 is 150. Again 150 is also in grams, so let us convert it into kg. So 150 upon 1000 kg. Now this kg and this kg will get cancelled. Degree Celsius will get cancelled. Now if I multiply these three terms, I already cancelled the 1000 also. Okay, kg, 1000, degree Celsius already are cancelled, and remaining will come out to be as, if we multiply the three terms, 50 into 2.77 into 1000, it will come out to be 138500 divided by, now here this is 7.21 into 150, that comes out to be 1081.1, and the unit that are remaining, these have been cut. Degree Celsius is also cut. Remaining is kg per mole, so we will write kg per mole as it is. So M2 will be equals to, if I divide these two, I will get the answer as 128 kg per mole. Okay, so this is the answer for the molar mass of the solute if the value of Kb is 2.77. Okay, have you all understood this? This is very simple boiling point elevation, and after this the third point, that is the third colligative property, that is freezing point depression, is also same as that of the boiling point elevation, that we will see in our next video. Okay, so hope you all have understood everything, and if you have any query, if you have any doubts regarding, you can ask me in the comment box. Okay, and if you like my video, then please let me know it, so that your likings give me the motivation. So please, if you like my video, then just give a like to it. Until then, bye bye, see you in the next video.